Hello students, welcome to Learner's Planet, Theory Session 8 of Metals and Non-Metals. In my previous session I was telling you about the methods for the concentration or dressing of ore. We discussed about the gravity separation and the froth flotation. Now in this session we will do magnetic separation, that which is one of the process of concentration of ore, and also about the extraction of less reactive elements like mercury, and also about the conversion of concentrated ore into its oxide. So now let's start with the magnetic separation. So what is magnetic separation and for what type of ore it is employed? Now your magnetic separation is, what is the principle behind it? This method can be used for separation of ore in which one of the component is magnetic. So students, it can either be the metal or the impurity, but one of them should be magnetic. Let's see how this process takes place. The process, what is done here is a magnetic separator. It is a equipment used there. Consists of a belt moving on the two rollers, one of which is a strong magnet. Now what is done is, the powdered ore is dropped on the belt from one end. Which end? From the non-magnetic end. And the other end, that is the magnetic. The magnetic particles, the other end is the magnetic. So what is happening, this magnetic separator has got two ends. One is non-magnetic and other is magnetic. So the other end magnetic, the magnetic particles are attracted and fall nearer the roller, and non-magnetic particles fall away from the roller. Now let's see this. For whatever for it is done where either the ore or the impurity is what? Is magnetic. Now the ferromagnetic ores are separated by this method. What is its example? It is wolframite. That is, it is iron. W is the symbol of, do you know what is the symbol? W is the symbol of? W is tungsten and oxygen. So this is wolframite. Now let's see the process how it is done. This is what? Say this is your magnetic separator. Now this particular roller is what? It is a magnet. Sorry, this is a non-magnetic part. And there is a conveyor belt over it, and we have got electromagnets here. Now, what is done is, we are pouring in the powdered ore. From which side? From the non-magnetic side. And this is moving over the belt, moving over the roller, and it is dropping down. So, what happens? The magnetic ones, they move along with the roller and they drop down. Whereas the gangue particles, students, just see the difference. Your magnetic ore has come till here, and your gangue particles, they are falling and moving a separate heap. They'll fall from here only. Why? From here. What has happened? They'll fall from here only. Why? Because they are non-magnetic. Whereas the one which is magnetic will move till here, and then it will be dropped. So by this method or by this process, we will get two separate heaps. One of the gangue particles and other the magnetic ore. So this was your magnetic separation. Now students, these are the methods which are employed for the separation of gangue particles from the ore. We'll do it in details when you'll be in your 12th or the higher secondary, right? If at all you are going for science. Now our next is, let's start with the extraction. Now we have separated the gangue particles. Now our responsibility is to remove the metal from that ore. So extraction of less reactive metals, like extraction of mercury. How does mercury exist? It exists in the form of cinnabar. Or how is from which ore your mercury is extracted? It is extracted from cinnabar. And cinnabar is what? Cinnabar is mercuric sulfide. Now what is done? Mercury is a less reactive metal. It can be extracted by heating its sulfide ore in air. Now students, had the metal been highly reactive, what will happen? While heating, the metal will react with the oxygen of air. So mercury being less reactive, it can be extracted by just heating mercuric sulfide. So what is done is, the concentrated mercuric sulfide ore is roasted in air when mercuric oxide is formed. So this mercuric sulfide is heated in the presence of lots of oxygen when it gives what? When it is giving mercuric oxide and sulfur dioxide. So in a way your sulfide has been converted to oxide. Now let's take up its next step. It is mercuric oxide, that is HgO, is then reduced to mercury on further heating. So this mercuric oxide is heated further and we will get what? Mercury and oxygen. So students, mercury is a very less reactive metal and its extraction is easy also. It can be extracted just by heating mercuric sulfide ore in the presence of lots of oxygen. Now once that is converted to mercuric oxide, the oxygen supply can be reduced or it can be taken off. So then you'll get what? Then you'll get your mercury and oxygen. So this is how mercury is extracted. Likewise, copper can also be extracted from copper glands. That is what? That is copper sulfide. Now in this, what is done is, the concentrated copper sulfide, Cu2S is copper 1 sulfide, is roasted in air when a part of copper 1 sulfide is oxidized to copper 1 oxide, or it is cuprous sulfide to cuprous oxide. And it is converted to what? It is converted to cuprous oxide. Now, so your copper sulfide is heated in the presence of air and it will form what? Copper oxide and sulfur dioxide. Normally this copper is extracted from copper pyrites, that is CuFeS2, because the yield in this case is less. Now let's see how copper is extracted from copper oxide, or copper can be obtained from copper oxide. The supply of air is stopped when major amount of copper 1 sulfide is oxidized to copper 1 oxide. So after the copper sulfide has been oxidized to copper oxide, the major amount, what is done is, the oxygen supply is stopped. In the absence of air, copper oxide formed reacts with the remaining copper sulfide, forming copper metal and sulfur dioxide. So that is your cuprous oxide. Whatever cuprous oxide is formed. See, what you have done is we have just heated copper sulfide in excess of air or the oxygen. As a result of which, what has happened? Copper your copper sulfide is converted to copper oxide. Now once this copper oxide is formed, the oxygen supply is reduced. Then what happens? Your cuprous oxide formed reacts with the remaining cuprous sulfide. So I can write here cuprous oxide formed reacts with remaining copper oxide or cuprous sulfide, forming what? Copper solid. Right? That is also called as auto reduction. Why it is called as auto reduction? Because here your copper oxide is automatically it is self reduction. It is reduced to copper without any supply of any reducing agent. That is, the mixture itself gets reduced. So this is also called as auto reduction. And let's proceed. It is extraction of moderately reactive metals. Now what are the moderately reactive metals? These are the oxides of moderately reactive metals like chromium, magnesium, zinc, iron, tin and lead cannot be reduced by heating itself. So till now what you have done is the ore is taken and it is heated, converted to its oxide. When it is heated in the absence of oxygen, you are getting your metal in hand. But here, in case of moderately reactive metals like chromium, magnesium, zinc, iron and tin, they cannot be reduced by heating only. So, they are reduced by reducing agents like carbon, aluminium. Now let's see how the process takes place. Extraction of moderately reactive metals. The metals in the middle of the reactivity series such as iron, zinc, lead, copper are moderately reactive metals and they occur in nature as sulfides or carbonates. You must have seen in the ore that the zinc exists as zinc sulfide or zinc carbonate. Now the metals can be easily obtained from their oxides by reduction as compared to their sulfides and carbonates. That is your zinc. Zinc is existing in nature as zinc oxide or zinc carbonate. Likewise, your lead. Lead exists in nature as lead sulfide. Now what can be done is either the zinc carbonate can be easily or can be reduced by any reducing agent to zinc, or lead sulfide can be reduced by any reducing agent to lead. But what happens that metals can be easily obtained from their oxides by reduction rather than their sulfides and carbonates. So what is done for this? The metal sulfides and carbonates must be converted into metal oxides. So what should be done first is that their carbonates or sulfides or sulfates should be converted to their oxides. Let's see how it takes place. How it can be done. The concentrated ores can be converted into metal oxide by, there are two processes, one is calcination and the second one is roasting. Now what is calcination? So what is calcination? It is the ore is heated strongly in the absence of air to convert it into metal oxide. Now here students, it is not a complete absence. It's just that the air is not supplied from outside. There is no supply of air from outside. Now don't think that this particular process is taking place in vacuum. The ore is oxidized by heating and whatever air is present in the furnace. So there is no need of outside supply of air. Now here what is the furnace used? It is the reverberatory furnace. Now in this furnace the ore is kept at the bottom and then it is heated. See here I can keep my ore. So this is your ore. And it is heated to high temperatures. So this is heated. Due to which what happens that the whatever ore you have taken, you can take your zinc carbonate or you can take, this is in the absence of air, or you can take bauxite, that is Al2O3 2H2O, or you can take hematite, that is Fe2O3. So basically this process is for carbonates and oxide ores. So the type of ore for which calcination is done are carbonates and oxides. Now as the result of heating in the absence of air, or as a result of heating, some molecules are released. Now these molecules are carbon dioxide, which is obtained from carbonates, and water from hydrated oxide ores. So hydrated oxide ores, what is the example here? It is bauxite. So water is given out. Now what happens to the physical state or the properties of the ore? What changes are taking place? So effect on ore. It becomes porous as moisture is expelled from the ore. Now if I'm heating aluminum oxide and 2H2O, what will happen? This particular water molecule will be expelled out. See, let's take this examples here. Calcination of bauxite. Bauxite is Al2O3 2H2O. It is an ore of aluminium. Now this bauxite is heated in the absence of air in a reverberatory furnace. When we'll get what? We'll get aluminium oxide and water. Now this aluminium oxide is also called as alumina. Is called alumina. Likewise, the calcination of limestone. Now, what is limestone? Limestone is calcium carbonate, right? So, when this calcium carbonate is calcinated, that is when it is heated in the absence of air, what are we getting in our hand? We are getting calcium oxide and carbon dioxide. From here further, your aluminium is obtained by electrolysis of alumina. Whatever we have obtained after calcination is subjected to what? It is subjected to electrolysis. After electrolysis, what are we going to get? We will get aluminium, right? So this is aluminium. This is the next process, next step rather. And calcium oxide. From calcium oxide, we can get to the calcium. That it can also be done by electrolysis, because the calcium is again a reactive metal, or we can just heat it in the presence of a strong reducing agent. Normally, calcium is extracted from calcium chloride by its electrolysis. Now we have got another example here, that is calcination of malachite. What is the formula of malachite? It is copper carbonate and CuOH twice. This is actually the layer that is a greenish layer formed on the copper utensils is of basic copper carbonate, that is your CuCO3 CuOH twice. That is a very thin layer of this. Now that also exists in nature as ore. Now what is done is, what we are doing is, we are heating it in the absence of air. And what are we going to get here? We will get copper oxide, that is copper 2 oxide we are getting. Carbon dioxide and water are expelled out. So what are removed out is carbon dioxide and water. And what are we getting from here is copper oxide. So this is basically a process, or it is a process to convert the metal ores or the metal compounds to their respective oxides. Likewise, the calcination of calamine, that is zinc carbonate. Zinc carbonate is heated in the absence of air again, and we are getting what? Zinc oxide and carbon dioxide. So you must have seen that in every reaction, in every example, small molecules of carbon dioxide or water are removed out. Now, as the result of which, what happens? The ore becomes porous. The porosity of the ore increases. Now, what would be the next step? The next step would be the reduction of these oxides using agents, or using chemicals, or using elements like carbon or aluminium. So now I'll conclude this session. In our next session, we will do the second type, or the second method, in which we are converting the sulfides or the sulfate ores into their respective oxides. In order to convert sulfide or sulfate into oxide, we need a lot of air, or a lot of oxygen is required. So, roasting is done in the presence of air. So we are going to do this in our next session. I hope you have enjoyed this lecture. Thank you very much for listening patiently, and have a nice time ahead.